Hey everybody, today we're going to cover the very last section in this unit, 6.5, multiplying and dividing polynomials with monomials. Now what we did last time was we took a monomial and we took another monomial and we saw how we multiplied these single terms with each other. What we're going to do now is take something that has more than one term. So it could be a binomial, it could be a trinomial, it could be something with 4 or 5 terms, and see how we multiply that out with another monomial. So to multiply a polynomial with a monomial, we use the distributive property. You all remember the distributive property? Let's see it in action. If we were to take a monomial like 2x, a single term polynomial, and we wanted to multiply it by 5x squared minus 3x plus 7, we would use the distributive property and we would say, all right, this 2x needs to be multiplied with each term in this other polynomial, which means I need to do 2x times 5x squared. And we already learned last time how to do that. We multiply the numbers with the numbers and the variables with the variables. So 2 times 5 gives me 10. X times x squared is x cubed. And then I move on to the next term. So now this 2x needs to be multiplied by negative 3x. So 2 times negative 3 is negative 6. X times x is x squared. And now it's time to move on to the very last term. So this 2x also needs to multiply with the positive 7. 2 times 7 is 14, and the x remains x. And there you have it. That's how you multiply a polynomial by a monomial. Let's take a look at a couple more examples, and then we'll get into division. All right, let's multiply the following. Let's take negative 3x squared. We'll multiply that by negative 2x squared plus 3x minus 1. There you go. A lot more negatives to work with here, but the rules are the exact same. You multiply each term in the polynomial by the monomial, and then you take coefficients with coefficients, variables with variables. So here we go. First up, negative 3x squared with negative 2x squared. Well, negative 3 times negative 2 gives me positive 6. And then x squared times x squared, we can add the exponents together here using our exponent law, gives me x to the power of 4. Next up, negative 3x squared needs to multiply with positive 3x. Negative 3 times positive 3 is negative 9. And then x squared times x is x cubed. Lastly, negative 3x squared needs to be multiplied by negative 1. And so negative 3 times negative 1 is positive 3. And x squared is still there. And there you go. This is our product, the answer to our multiplication problem. Let's do one more and then we'll move on. Let's call this example A. And let's do an example B. All right, this one, I'm gonna have 7 plus 6x minus 2x cubed, and multiply this by 4x squared. All right, this one is arranged a little bit differently. You can see that the monomial is on the right side, but the rules still apply. I basically need every term in the trinomial to multiply with the monomial. And so this sugar property still applies here. We're just going in a slightly different direction. If you want to, you can always just move the pieces so that they look a little bit more familiar, but we can still work this out by doing the following. 4x squared needs to multiply with each term in the other polynomial, so let's start with the first one. 4x squared times 7 is going to give me 28. X squared. 4x squared times 6x gives me 24 x cubed. And then 4x squared times negative 2x cubed gives me negative 8. And then x to the power of 5, right? We multiply the exponents 3 and 2 to give me 5. And so now I have this polynomial, but we're not quite done there yet. Remember that when we're writing out these polynomials, we typically like to rearrange them to make sure that the highest degree term is on the left, and then it works its way down in degree. So I'm going to rearrange this. The highest degree term here is that x to the power of 5 term. So that negative 8 x to the power of 5 should be in front. The next highest is this x cubed term. And then the lowest degree term is this x squared term, which I'm going to tack on over here. And then finally, this is my answer. All right, let's move on to division. So when dividing polynomial or rather, when dividing a polynomial by a monomial, each term in the polynomial is divided by the monomial. Okay? So much like multiplication, every term in the polynomial gets multiplied by that single term monomial. When we're dividing, we do the same thing. Each term in the polynomial gets divided by that one term monomial. Let's see what this looks like. We had 14x squared minus 21x, and we wanted to divide the whole thing, and so I'm going to indicate that by drawing a line under it. We want to divide the whole thing by 7x. What we would do is we would take each term and divide each term by 7x. So this 14x squared gets divided by 7x. 14 divided by 7 is 2. X squared divided by x is x. And then the next term, negative 21x. Negative 21x divided by 7x. Negative 21 divided by 7 is negative 3. X divided by x is 1, so that cancels each other out. And so there's no longer a variable in this term. This is my final answer. Let's take a look at a couple more examples and then we're going to be done for today. Let's divide the following. Let's take 12p cubed minus 6p squared plus 3p. And we want to divide this whole thing by 3p. Okay, so we learned from before that we just take each term and divide it by, in this case, 3p. Let's do that. 12p cubed divided by 3p is 4p squared. And then 12p cubed is done, so next is negative 6p squared divided by 3p. Negative 6 divided by 3 is negative 2. P squared divided by p is p. And then this last one, this is where a lot of mistakes will happen. People will see this and see, 3p divided by 3p. Okay, so the 3 and the 3 cancel out, the p and the p cancel out, and so it's just gone. And a lot of people will just leave it like this. But that's not right. If you divide 3p by 3p, you don't get nothing, you get 1. Okay? So 3p divided by 3p isn't nothing. It cancels each other out and leaves behind a 1. So that means that 3p divided by 3p gives me a positive 1. And you have to include that as part of your polynomial. Okay? You can't just leave it out and that would be wrong. So if you did this, that's incorrect. You forgot the term and it's a completely different polynomial. So make sure you don't fall for that trap. That is the final answer. Okay, let's do one more. I'm going to show you one with some decimals. So 1.8g squared minus 12g divided by negative 0.3g. Okay. Having decimals doesn't really change anything. We use the exact same rules. So each term gets divided by this monomial. So 1.8g squared gets divided by negative 0.3g. 1.8 divided by negative 0.3, I know that it's going to be negative. And then 1.8 divided by 0.3, okay, remember that you can either work this out by shifting the decimal points, okay, and essentially do 18 divided by 3, or you can just use your calculator to calculate this. Okay, this is going to work out to be 6, negative 6. And then the g squared divided by g, no calculator needed there. That just gives me g. And then the next term, negative 12g divided by negative 0.3g, turns out to be positive 40. Okay, so you still apply the exact same principle. Coefficients divided by coefficients, variables divided by variables, and then you are done. All right, so now you know how to multiply and divide polynomials by monomials. The types of problems that you're going to see this associated with are usually either just straight up here are the polynomials, multiply or divide them out. Sometimes you may see something like, here's a rectangle, okay, and I'll give you the length and I'll give you the width. Please calculate the area. Well, we know how to calculate the area of a rectangle. We would multiply them. Except instead of giving you numbers for the length and width, they might give you a polynomial. So they might say, all right, here's my length is 2x plus 5, and my width is 3x. find the area. Well, you would have to multiply these together, and now you know how to do that. Okay? They might go the other direction. They might say, hey, here's another rectangle. I know the area. My area is 4x squared plus 8. My width is 2. Can you find the length for me? Okay, so if I know the area and I know the width, I know that I can find the length by dividing. Take the area, divide by the width, and then you have your length. So these are types of scenarios that you may come across, and you should be able to handle them. All right, that's it for today. See you in the next one.